For the following exercises, evaluate the expressions, writing the result as a simplified complex number. Okay, so I know that in the last question I said that one was the last question for this playlist, the complex number playlist. However, this one is the last one. So we have one more to do, all right, guys? If you guys aren't on the playlist or you want to see all of our complex number, imaginary number questions that we have done to help you guys in your math class, go in the description. The link will be in the description below, so you could check that out. Okay, so let's just simplify this one. So we've done tons of problems already, so we kind of know the gist, right? So let's just run through it. So we have 3 plus 2i, all divided by 1 plus 2i, and minus 2 minus 3i, all over 3 plus I. Okay, so according to PEMDAS rules, right, I'm definitely going to divide first before I subtract the two fractions, right? So I'm looking at this and I'm saying, well, there's really nothing I can simplify here, right? So, but there must be something, right? But the key thing is that, and I'm going to put it up here, is that I values, I stands for imaginary. They are not real, so they're non-real values. I can never be in the denominator. That's the problem here. So that's the first step in which we're going to be able to do something with this. I see that I, the imaginary value, is in the denominator here, and I see that I is in the denominator here. So I'm going to have to do something to both of these fractions so that the i's go bye-bye. Did you get that? The i's go bye-bye in the denominator. Now, we've seen this time and time again, right? If we want to get rid of the I, all we have to do is multiply by something that is the opposite of what's being done. So in this fraction, the denominator is 1 plus 2i, so I will divide the whole thing by 1 minus 2i. I have to divide by the opposite of what's being done. But you can't just leave it like that. You have to be fair. Whatever you multiply by the denominator, you got to multiply by the numerator. So the numerator is going to have the same thing. And that's how we can basically multiply things in thin air, because technically this will break down into just a 1. So you're really just multiplying by 1. However, we can do the theoretical math to just get that I out of the denominator. So that's what's going on here. I have basically these two things being multiplied by each other for the numerator, and I have these two things being multiplied by each other by the denominator. So I have to do this multiplication for the numerator and get that answer. And then I have to get this multiplication for the denominator. Now let's work on the other side. Well, this side, in this fraction, the denominator is 3 plus I. So if I want to get rid of it, I have to multiply something that's the opposite of this, and it would be 3 minus I, right? So let me just write that in, because I like to color code everything. 3 minus I. And remember, I can't just multiply just the denominator, I got to be fair. So I'm going to multiply the top by 3 minus I. And then that brings us to what we're going to do. We're going to multiply these two things together on the numerator, and then I'm going to multiply these two things together on the denominator to get one single answer. So I have to do those things as well. And then do this. And then finally, once we get those 4 answers, I'm going to subtract the 2. So let's just number these. We're going to say maybe this is number 1, doing this numerator multiplication. Then I'm going to do this. Then we're going to move on to the second fractions, okay? So we have to get the 4 parts first, and then we're going to simplify. So let's start all the way over here. 1. I'm going to do this multiplication. So this is going to be 1 minus 2i all times 3 plus 2i. And now we do this multiplication where we got to be fair. We have to multiply the 1 by the 3 and the 2i But then you also have to do the same thing for the second term. So I have to multiply the negative 2i by the 3, and I have to multiply the negative 2i by the 2i. So let's try it out. 1 times 3 is 3. 1 times 2i is a positive 2i. 1, just kidding, I moved to the next one. So negative 2i times 3 is a negative 6i. Negative 2i times 2i is a negative 4i squared. Let's clean this up. It looks like I have common variables in the middle. I both have I values here. So I have 2 minus 6, which would just be a negative 4. And then you just strap on that I. So it would be 2i minus 6i is just a negative 4i. And then you bring down whatever else you had. So it would be 3 minus 4i minus 4i squared. Now, simplified complex notation, you're only allowed to have just single I values. I cannot have anything that's greater than an I. So I can't have I to the second, or I to the third, or I to the fourth. So I need to somehow get rid of this I squared. Now this goes back to what I really means. And I is the square root of negative 1. That's what all these I values mean. So, and basically that's what makes it imaginary or non-real. If you put a negative 16, the square root of negative 16 into the calculator, the calculator is going to say error because the calculator only can calculate real values. If you have a negative and a square root, it's automatically non-real. It's imaginary. It's not a real solution. So if I take this idea and I'm saying, okay, well, I want to find out what I squared is, I'll just square this, right? Which means that I just have to square this. And what is so special about a square root being squared? Oh, they're opposites of each other. So that gets canceled out. So this idea is that I squared really just equals the leftover, which is negative 1. So anytime that you see an I squared, you just plug in. So for this one, I see an I squared. I just plug in a negative 1. So this would now be 3 minus 4i minus 4 times a negative 1. And a negative 4 minus 1 is the same thing as a positive 4, right? So I can just get rid of this. And then I just simplify. So 3 plus 4 is 7. And then 7 minus 4i. So that is the answer to the first part, which is this. So maybe I will just put this over here, right? If I put a fraction here, I just figured out the first top part. I know this one's going to be crazy, so maybe get some coffee or some tea. The answer to this part was 7 minus 4i. Now we have to do the same thing for the bottom here. So I will do that in number 2 over here. So number 2 is just going to be multiplying the denominator by this. So I'll put it over here. 1 minus 2i times 1 plus 2i. And the same idea. I have to multiply the first term by the 1 and by the 2i. And then I have to be fair. I have to multiply the negative 2i by the 1 and by the 2i. So let's get it started. 1 times 1 is 1. 1 times 2i is a plus 2i. Negative 2i times 1 is a negative 2i. And then negative 2i times 2i is a negative 4i squared. Clean this up. I have i's in the middle, but a 2 minus 2 is 0, so they cancel. So now we're just left with 1 minus 4i squared, and we know that I squared, right? We know that this I squared was just a negative 1. So this is 1 minus 4 times a negative 1. And a negative 4 times a negative 1 is a plus 4, so I can just get rid of this. And then 1 plus 4 equals 5. So that's what I have in my denominator for the second thing. Okay, halfway there, guys. Now it's this simplified fraction minus this big thing over here. So I'm going to do 3 up top here. That's multiplying the numerator. So I have 2 minus 3i times 3 minus I. I have to multiply the first term. Let me make that a different color. I have to multiply the 2 by the 3, and then I have to multiply the 2 minus the negative I, and then I have to come back around, because I have to be fair. I got to multiply that negative 3i by 3 and by the negative I. So let's start it off. 2 times 3 is 6. 2 times the negative I is a negative 2i. Negative 3i times 3 is a negative 9i. Negative 3i times a negative I is a plus 3i squared. Clean up that second term right in the middle. So this would equal negative 2 minus 9. Negative 2 minus 9 is negative 11. So negative 11i. And then I just drag the rest down. So this would be 6 minus 11i plus 3i squared. Get rid of that 3, get rid of the I squared, right? I squared is just negative 1. So this would be 6 minus 11i plus 3 times a negative 1. 3 times a negative 1 is a negative 3. So I can just put a negative here and get rid of this. Clean it up now. 6 minus 3. 6 minus 3 is 3. So that would be 3 minus 11i. And that's the answer to the numerator part. So I'm going to add my next fraction. And now I know this, the third piece to the puzzle is that. And now I just have to do this. So I'll say that as down here, number 4. Is I'm multiplying 3 plus I times 3 minus I. Same exact idea. I got to multiply the 3 by the 3 and the negative I. But then I got to be fair. I got to multiply that I now by 3 and a negative I. So let's give it a shot. 3 times 3 is 9. 3 times a negative I is a negative 3i. Moving on to the second term. I times 3 is a plus 3i. I times a negative I is a negative I squared. Clean up that second term. And when I say second term, I just mean the things in the middle, right? Negative 3 plus 3 is 0. Oh, they go bye-bye. So now what I have left, I'm just putting an arrow here because I know the subscribe button's somewhere over here. And if you want to click the subscribe button, you can. But if not, that's okay too. But we must continue. So I now just have 9 minus I squared. And we know that I squared is the same thing as a negative 1. So 9 minus a negative 1. Keep change. This is just 9 plus 1. So the bottom would just equal 10. Woohoo! Okay. Now, I must simplify this jazz. Okay. So let's see. I actually want to move this over a little bit because I do see that I have... Oh boy. I might just erase it because I want to have like a little room here. So let's see. I'm just going to erase a little bit. So pause the video if you want to copy down everything, but I'm just going to erase a little bit. I'm going to erase over here. Whee! And I'm going to erase just this part over here. Okay, just so that I have room. Now, I want to simplify this, but I can't do the subtraction unless I have common denominators, right? But this looks a little simple. I have a 5 here and a 10 here. Can I get a 5 into a 10? Yeah, right, because 5 times 2 is 10. So if I just multiply the denominator by 2, I will get 10. However, just like the idea that happened here, I have to do the same thing for numbers. If I multiply the denominator by 2, I sure as heck have to multiply the top as 2 as well, right? So this goes into another like simplifying process. So I'm going to multiply these, and then I'm going to multiply these. I don't have to do anything with this guy because this already has the 10. So let's do it. I'll do the numerator first. So 2 times 7 minus 4i, right? I'm just doing this part. So 2 times 7, and then I have to do 2 times a negative 4i. So this would be 2 times 7 is 14 minus 8i. And that is now being divided by 2 times 5 is 10. So I can say now that I have 14 minus 8i over 10 minus 3 minus 11i over 10. And I don't like how this looks. So maybe I'm just going to substitute it into here, okay? So what we just said was that this top part now is the 14i, right? The 14 minus 8i, and it's now over 10, right? So I'm just going to get rid of this because we did all the math. So now I have that. And let me just move this down over here just so that you guys have the math. Okay. Now I'm going to break it up into its different components. I want to make these fractions into its real and imaginary components. So remember, if you have multiple things in the numerator, all being divided by a denominator, you can break these fractions up. So the first thing I'm going to do is I'm going to do 14 minus 10, 14 divided by 10, right? This can get broken up into 14 over 10 minus, because there's a minus sign here, 8 over 10. So 8i over 10. And this is now being multiplied, this is now being subtracted by the whole thing, and I could break this up as well, right? This could get broken up into 3 divided by 10 minus 11i over 10. Now I have to put these parentheses here because it's being multiplied by the whole fraction. And I broke the fraction up into 2 parts, so I just want to make sure that everything is nice and neat in there. So now we're down to this. Now I just have to substitute or simplify that. I need to erase some more things, so I'm going to erase on the right-hand side. So I'm going to erase all of this stuff. So once again, if you need to pause the video, just pause it, but that has to go. Okay, so now I'm just going to group together my real terms, which is the 14 over 10 and the 3 over 10. They're not the ones that have the i's in it. So I'm going to basically group together all the i's and then the non-i's. So the first thing I'm going to do is I'm going to do 14 over 10 minus 3 over 10. I have a common denominator already. When you are subtracting, you just keep that denominator. So this would be 10. And then 14 minus 3 is 11. You actually do the subtraction, right? So 14 minus 3 is 11. So that is the answer to my first part. Now, I'm just going to subtract the second part. So I have a negative 8i over 10 minus a negative 11i over 10. So I'm just going to write that down. So I have a negative 8i over 10, right? And just make sure that you use those signs. There was a negative here, so I have to keep that. Negative 8i minus 10 minus negative 11i over 10. Same thing is happening here. The 10 has to be the same, so this is something over 10. And then negative 8 minus a negative 11. Keep change. So this is negative 8 plus 11. So 8, 9, 10, 11. So this would be a 3i. So now I'm just going to simplify this. You're basically done. You have your real component and your imaginary component. So I'm going to just write the answer over here. The real component after we added everything was 11 over 10. That's this. Plus your imaginary component, which was 3i over 10. And finally, that is the answer. Oh my goodness. But understandable. This is the last question of the playlist. So if you guys can do this, you guys are masters of complex numbers, imaginary numbers. But as you can see, it's just multiple steps. The math isn't really that hard. It's just doing so many steps over and over and over again. So I hope this has helped you. If you want to hit the like button, hit the like button. That just, makes us know that we're doing our job right. If you want to subscribe, the button's right over here. And I thank you for that. But if not, I love you guys anyway. You guys have been a blast. I love talking to you guys. So leave something in the chat, all right? Or the comment box or whatever it is. So I hope you guys have a great day. Keep studying hard. I'll see you guys all in the next chapter, which I think is polynomials. Ooh, polynomials. But other than that, good luck on your exams. And I'll see you guys all in the next lesson. Have a great day. Bye.